All right, so we've just seen some examples of different kind of preferences and what their indifference curves are going to look like. But when we want to talk about preferences or indifference curves in general, it's going to be really useful to kind of concentrate on specific kind of shapes and things like that. And so what we're going to do now is kind of discuss what we might call well-behaved preferences. So let's just write out what I just said, just so we have it in our notes. If we want to discuss preferences in general, it will be convenient to focus on a few shapes. So we're going to start by making a few general assumptions about these preferences, and that's going to lead to certain shapes of indifference curves. So we will make a few general assumptions. About preferences. And their implications on the shape of indifference curves. That's supposed to say curves. All right, so that's what we're going to do now. So I'm going to erase this and we're going to go through the different assumptions and kind of talk about what that means for the shape of the indifference curves. So the first assumption we're going to make is this idea of monotonicity. I'm going to put this in layperson's terms. You might say more is better. So this is the first assumption we're going to make. So what this kind of means, more or better is, kind of the idea behind it. Let's just be a little bit more concrete with it. If we have two bundles, and we have x, which is some amount, x1 of good 1 and x2 of good 2, and y, which is y1 amount of good 1 and y2 amount of good 2, where bundle y has at least as much of both goods, and more of 1. Then we prefer this bundle y to bundle x. Strictly prefer. Maybe that's kind of weird wording, but for example, let's say x1 is the same as y1, but y2 is a bit larger than x2. That kind of satisfies this, and if that's satisfied, then we prefer this bundle to that bundle. So remember, that's strictly preferred. So essentially what this means is we are dealing with goods rather than bads. And we're not reaching satiation. So we don't have like a bliss point either. So what is the implication for this in terms of our indifference curves? Implication is that there's a negative slope. Indifference curves that satisfy this monotonicity assumption have a negative slope. All right, so that's our first assumption. The next one is going to be convexity. So let's quickly erase that. do the same kind of thing for this next assumption. So the second assumption that we're going to make is convexity. So think of this, I'm not sure if I did the double arrows or what I did before, is the idea is that, you know, the averages are preferred to extremes. So that's kind of like the layperson's way of thinking about convexity. But again, let's be a little bit more precise. So if we have two bundles, again, let's say bundle X and Y. On the same indifference curve, then a weighted average of these two bundles is preferred. So mathematically, what that would say is, you know, x1 and x2 is indifferent to y1 and y2 because they're on the same indifference curve, right? So we're indifferent between these two bundles. Then a weighted average. So we're going to weight it by t. So t is between 0 and 1. T times x1 plus 1 minus t times x2. And t times x2 plus 1 minus t times, this should be y1, sorry about that. So the amount of good 1 is a weighted average of the amount of good 1 in each of the bundles. And the amount of good 2 is a weighted average of the two bundles, the two amounts of good 2, so this should be y2 here. This is going to be preferred, weakly preferred, to bundle x1, x2, and same with y1, y2, for any t between 0 and 1. So let's write that out, 0 and 1. Obviously, if it's, you know, if it t equals 0, then we're really just taking y1 and y2, and so that's why it's like weakly preferred. All right, so the implication for this, so this is just mathematically taking a weighted average, where the weight on bundle X is t, and the weight on bundle Y is 1 minus t. So the implication for this, as the assumption name kind of implies, is the set of all weakly preferred bundles to, let's say, bundle X is a convex set. So it has implications on the shape of this indifference curve. The set of weakly preferred bundles to bundle X is a convex set. So let's erase this board and let's kind of visualize, you know, let's draw some indifference curves and visualize what we mean by this. So let's kind of visualize what that assumption about convexity means. So let's draw 3 different kind of examples of the difference curves. Again, good 2 on the y, good 1 on the x. Got to make sure we label everything. All right, so let's first think about what a convex indifference curve would look like. So here's, let's call this I1. Let's do a different color. Let's say this is bundle X, this is bundle Y. Well, if we draw a straight line between them, that's all the different possible convex combinations of those two. right? Right in the middle is if we weight them 50-50, but we could weight them anything between 0 and 1. That capital T that we are just writing down here in that equation. And so notice that any bundle, along this dotted line is preferred. That's going to be on a higher indifference curve than I1. So that's going to be a convex. They have this kind of bow shape. Another example of something that's non-convex would be something like this. And again, let's say x up here and y down here somewhere. And if we put it a weighted average, it's going to be like a straight line between them, or a dotted line, depending on what weight we use. Well, here, this bundle is on a lower indifference curve. So this is non-convex. It's kind of crazy shaped, right? The other one we might want to draw is something that looks like this. So here's another indifference curve. Label my indifference curve, so here's I1 again, and let's say this is I1. Well, this is, these are concave, which kind of means that the weighted average is less preferred than just the bundles themselves. So we have x and y. Again, we have this situation where something in the middle, or some convex combination of these two bundles, gives a lower utility. And so we're thinking about the preferences that we're describing here kind of have this bow shaped. So let's kind of write that out. Basically, we're looking at situations where we want to consume the goods together. Where a consumer, again, wants to consume, individual wants to consume the goods together. Some of each good, They prefer some of each than extreme amounts. So an extension to this would be strict convexity. And this is where the weighted average is strictly preferred. Is strictly preferred. So a weighted average gives higher utility, whereas when we gave the definition of convexity, remember it was weakly, at least weakly preferred to. If we have strict convexity, then they're strictly preferred. And what this means is there's be like no flat spots on indifference curves. For example, remember we looked at perfect substitutes. We had those, constant slope and difference curves. Those are convex, but they're not strictly convex.